Okay, so now we need to think about using truth tables for slightly more complex arguments. Okay, so just looking over this argument that is already been formalized, right? So we've already taken the natural language argument and translated it into propositional form. Okay, we notice that there's a bit more going on than in the last argument. So modus ponens arguments can be really straightforward. If P then Q, P is the case, therefore Q is the case. Okay. Now, looking at this argument, we notice that there are more symbols. There's an additional letter. Okay, and we need to think about the steps required when there is an additional letter variable and there are additional symbols for the logical operators. Okay, now, it might look a little daunting, but as long as we are methodical and we use the correct steps and the correct procedure, it's not going to be difficult at all. Okay, so like we did with the modus ponens truth table, we need to start by figuring out the truth values for the individual letter variables here. Okay, so we're going to use the handy-dandy formula here for determining how many combinations of truth values there will be given the distinct number of letter variables here. Okay, so we have the letters A, B, and C. So we need, looks like 8 rows. Okay, so it's going to be a much longer truth table, okay, given that there is the third letter variable. And, just to give you an idea, if we had a fourth letter variable, let's say, for example, D here, it would be 2 to the fourth, and that would give us a 16-row truth table. Okay, now it's worth pointing out that with more than 3 letter variables in a truth table, it gets really time consuming and it kind of defeats the purpose of using the truth table to determine validity. Okay, and this is where natural deduction proofs will come in handy when we have many letter variables. Okay, now what we need to start with then is assigning the truth values. We know that there are going to be 8 rows of combinations of truth values, and like we did in the modus ponens truth table, I'm going to start with the letter variable closest to this vertical line here. Okay, now I'm going to do like I did with the 4-row truth table. And for C, I'm going to apply truth values alternating by 1s until I get to 8 here. Okay, so I need 8 rows. So alternating by 1, true, false, true, false, true, false. Okay, I have 8 truth values now for C. Okay, I'm going to do the same for B, but instead of alternating by 1s, I'm going to alternate by 2s from true to false. Okay, so for B, it'll be true, true, false, and false, true and true, false, and false. Okay, now given that we have the third letter variable here, I need to assign it some truth values, and I'm going to double it this time for the alternation between true and false. So whereas B, it was by 2s, for A, it's going to be 4s, right? So 4 trues and 4 falses. Okay, the check again. The first row should all be trues. That's okay. Last row, all falses. So we have distributed the truth values accordingly. If there was indeed a 4th letter variable and we were going to be constructing a 16-row truth table, then for that 4th letter variable, we would alternate by 8s, okay, and double it that way. Okay, but given that we only have 3 letter variables, we're done. Now, the next step is to take these truth values for the individual letters and input them wherever they are found in the argument. Okay, so I'll start with A, and wherever A is in the argument, I'm going to input these truth values. Okay, so I see A is the antecedent in this conditional. Okay, so I'm just going to take the truth values for A and input them there. So true, 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 false, 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 and false. Okay. Moving on to B here. So true, true, false, false, true, true, false, false. Wherever B is in the argument, I'm going to insert those truth values. So I see B in the consequent of this conditional. So input those truth values. True, true, false, and false. True, true, false, and false. Okay. Similarly, in the conclusion, I will assign the truth values for B there, since B is our conclusion. Okay. Final letter variable, C. So input the letter variable, or truth values for C here. So true, false, true, false. Whoops, wait, true, false. My mistake. False, true, false, true, and false. Okay, and here. True, false, true, false, true, and false. Okay, truth values have been inputted into the truth table. Now the fun part, the symbols, okay, the logical operators. Now, looking over the premises, let's not worry about the conclusion just yet. Specifically, looking at the first premise, I noticed that there are 3 different operator symbols. We have the negation here, we have the condition arrow, and we have the wedge for the disjunction. Okay, now, it's really important when completing the truth table, when we have premises like this with multiple operators, to figure out which operator, which symbol is the main operator. Which symbol governs the logic of the entire sentence, okay? Now, you could use, some sort of math type reasoning here, order of operations. That is appropriate in this context, not in all contexts in propositional logic, but that's a shorthand way of identifying the main operator here. Okay, so which is the operator that is at the end of the order of operations here? Which are we going to figure out the truth values for last, said differently? Okay, now looking at the first premise here, okay, I noticed that the wedge here, it is holding the whole sentence together, right? So if I were to just read this in natural language here, it would read something like either it is not the case if A then B, or C. So notice that either or captures everything else in the premise. Okay, so it is the main operator. So we're going to need to figure out these truth values last, okay, when determining the overall truth or falsity of the premise. Okay, so we need to work backwards now. So I noticed that the conditional here in the first disjunct, in the disjunct as a whole, right, it has this arrow. So we need to figure out when the conditional here is true or false, given all of these truth values. Okay, then we'll worry about the negation after that. Okay, so thinking about the truth definition for a conditional again, I know a conditional is false when there is a true antecedent and a false consequent. Okay, so I'm just going to look for those combinations first. Row 3, I see true antecedent, false consequent. So that is false. Similarly, row 4, true antecedent, false consequent. Okay. Now, looking in the subsequent rows here, I see only false antecedents. So I know that I'm not going to have a true false anywhere else for the conditional here. So I'm just going to assign trues for all the rest of them. Okay, given that there's no longer any combination of true antecedents and false consequence. Now, in arguments using truth tables where we have premises with multiple symbols here, keeping track and staying organized of where you are within the distribution of the symbols for the operator here is really important. So something I do is I cross out the truth values that I no longer need, right? I'm no longer concerned with these truth values for the conditional, given that we've already figured out what the overall truth values are for the sentence as a whole here, if A then B. Okay, now looking at the outside of the parentheses here, I notice the negation, okay? And the negation is operating over everything in the parentheses. In this example, a conditional, okay? So knowing that negation stands in for words like no, not, it is not the case, I need to negate whatever these truth values are in the column under the conditional here. So trues become falses, falses becomes trues. Okay, so here, true, so that becomes false, true becomes false, false becomes true, all the way down until I'm completed here. So, okay, it's really important that you are negating the correct truth values, right? Crossing these out indicates to me that I'm not going to be negating those. I'm going to be negating the truth values for the conditional. Okay, so given that the negation negates or operates over whatever is in these parentheses for the truth values, I don't need those anymore, okay, given that the negation is operating over the conditional. So we're almost done then with the first premise, okay? We're on to our last symbol. And as we saw, the either or is the main operator. It's the logical operator that acts as the glue for the whole proposition. Okay, so now we need to figure out when the disjunction is true or false, given these truth values under the negation and these truth values under C. Okay? So thinking back to our truth definitions, a disjunction in either or proposition is it's true in 3 cases and false in only 1 case, right? So we know that a disjunction is false only if both parts of the disjunction are false, right? So technically, if both disjuncts are false, the whole disjunction is false. Okay, otherwise it's true, right? Remember that disjunctions, they express in at least one is the case relationship between the 2 parts in the disjunction. Okay, so I'm going to go through row by row here in our disjunction and look for a false-false combination of truth values. And then I know that the overall disjunction is false. Okay, so I see a false-false here. So that's false. Okay. I see a false-false here. So it's false. And in our last row here, false and false. Okay, so any other combination of truth values are automatically true for the disjunction. So a false and a true, that's true. A true and a true, that's true. True and a false, that's true. False and true, true. And false and true, that's true. Okay, so 3 falses in this particular distribution of truth values. Okay, so now that we have the truth values for the disjunction, the wedge here, we no longer need these truth values or these truth values. Okay, so the particularly tricky premise is now taken care of. Okay, all we have left is negation in the second premise and the conclusion. So we now have the truth values determined for the first premise here, right? The wedge here, the disjunction, is the main operator. So all we need to worry about is the truth values that fall under the wedge here. And we have those. So when we look for validity, we know where to check and what truth values to use. Okay, so all we have left to do now is to negate the truth values for C here, our second premise, and for the conclusion here, B. Okay, so I'm just going to overturn whatever the truth values are for C. So trues become falses, falses become trues. Okay, so false, true, false, true, false, true, false, and true. Don't need these truth values anymore. Okay, the negation is operating over whatever the truth values were for C. Okay, same thing works for B here. trues become falses, and falses become truths. So false, false, true, true, false, false, true, and true. Don't need those truth values any longer. Okay, so it looks like we're done with the technical components of the truth table. We've assigned the truth values for each individual letter variable. We have, we've accounted for all of the symbols given how they operate over certain parts in each of the propositions, especially here in the first premise. Okay, so I'm just going to notate here where I want to look in terms of truth values when we're looking for invalidity or validity, where we're going to go row by row and look for the TTF combination. Okay, so I'm going to look under the wedge here. I'm going to look under the negation in the second premise, and I'm going to look under the negation in the conclusion, right? Because the negation is operating over both of those letter variables. Okay, so here we just go row by row, like we did with the modus ponens truth table, looking for this combination, true, true, false. Okay, so here, true, false, and false, we're good, right? According to the definition of validity, an argument is invalid if it's possible to have all true premises in a false conclusion. Both premises are not true, so we're fine there. Okay, false, true, false, that's okay. True, false, true, that's fine. True, 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 that's great. That's the sound argument that we know about by now, right? When we have all true propositions. True, false, false, that's okay. Again, we want true, true, false, false, true, false, that's okay. And just looking at the last two rows, I see both true conclusions. So we're not going to find this combination, true, true, false. Indeed, it's true, false, true, and false, true, true. So what we have just demonstrated is that the argument is valid, right? We do not have that combination of truth values within the truth table. Okay, so when we started, it looked a little complicated, a little daunting perhaps, but as long as you take it step by step and stay organized and don't skip ahead, you're going to complete the truth tables accurately, and they won't really get any more difficult than this. So master this, and you're going to be great at completing truth tables.